I recently visited Dave Cranmer, aka Nervous Squirrel, and among the amazing things he's built is an incredible modular synthesizer. It's enormous. It's quite possibly the biggest synthesizer in the world. When I visited, obviously I took with me the smallest synthesizer in the world, and it was funny for the two to meet. But there wasn't much we could do with this. All of my stuff is MIDI and self-contained, and for the most part incompatible with the modular. I mean, you could filter the sound output, but So I decided that before my next visit, I would build a synthesizer with a pitch CV input, 1/4-inch jacks, and a nice big control panel with physical knobs and sliders. So I came up with this. The Hardware Reverse Oscilloscope Mark II. Just a quick reminder, here's the Mark I. And the Mark I itself was only ever meant to be a comedy hardware version of a much older software synth that I wrote. And it does capture some of the essence of drawing custom waveforms, but the original synth did a lot more than that. In fact, it was incredibly complicated. The interface was a complete mess. The problem is, with a software synth, it's so easy to add more knobs and sliders, one for every parameter, and forget that you're making it impossible for people to figure out how to use. The skill in designing a synth like this is to distill all of those parameters into the fewest possible knobs. An effect might have loads of things going on internally, but sometimes it's best to just have one knob that says, give me more, give me less. The glowy sliders are the waveform. This first knob is the period, that's how many of the sliders get used to produce the waveform. The next knob is the interpolation, that's how we connect the dots between the sliders. And in this position it's a flat line for every slider, but in the vertical position we draw a line directly between each slider. And if we keep turning the knob this direction, it will become a smooth waveform. The middle knob controls the number of oscillators, and the detune knob sets their spread. We can have up to 4 oscillators in 2 modes, clean or dirty, unison or chaos. And finally, we have the cyclic wave shaper, also known as the magic knob, a Mitzella special. And that's pretty much all there is to it. You'll notice there's no envelopes or LFOs or VCA because it's designed to plug into a modular. Unfortunately, I don't actually own any modular equipment. It's entirely theoretical. The only thing I've got that can send CV gate is this key step. I got this as a MIDI controller, and it's actually terrible as a MIDI controller, but now we finally have a chance to use it for its intended purpose, that is, pitch CV sequencing. The decision to go with illuminated sliders was obvious just because it looks cool, but I didn't realise how valuable that visual feedback would be. For all of the parameters, the arrangement I've gone for is that the knob and the CV input get added together, but once you've plugged something into there, it's suddenly quite hard to know what the resulting value is, with the exception of the first parameter, where we can see it. It's just immediately obvious what the effective value is. So something I'd like maybe for the Mark III is for every parameter to have a little bar graph showing what the resulting sum of the two inputs is. I did see something like that on some of the envelope modules, where there was just a single LED was enough to give you a visual indicator of attack, decay, sustain, release. It makes a huge difference. This is the simplest possible envelope generator. It's just a capacitor on the gate signal with two knobs and two diodes to control how fast it fills and releases. The main problem with this is that the shortest possible attack time is going to be based on the output impedance of the gate signal, which is almost certainly 1 kilo ohm. And the other problem is that you can't really scale the output without it loading everything, nothing's buffered. So there are 100k trim pots on the inputs on the synth, but those, I'd have to open it up to adjust those. This is not very convenient. So that at least gives you some idea of the sounds you can produce with this thing, though it's by no means exhaustive. For a start, I don't have any other modules to connect it to. As I said before, there's a delicate balance to strike between the simplicity of the controls and the diversity of sounds it can produce. I think I probably could have made the oscillator controls into just one knob, along with maybe a switch. There's a non-linear curve on the detune, but I think it would have been better if there was an inflection point around the fifth and the octave. Before I open up the box, let me just say that I built this very quickly, and what you're about to see does not represent my usual standard of work. Of course, the laser cut control panel looks beautiful, but what's inside does not. I know it's kind of cliche to say that I ran out of time, but in this case, genuinely, I'd set aside a couple of weeks to build this, and right at the start of it, something else came up that was very important, and the synth almost didn't happen at all. It was originally meant to be entirely in hardware, but that would have taken far too long to solder together. So I just shoved a bunch of microcontrollers in there and did it all in DSP. I cut every corner I possibly could. Nothing is buffered. In the end, there's only one op-amp in the whole thing. Pitch goes straight into a 16-bit ADC. All of the sliders, all of the knobs, and all of the jacks go into analog multiplexers, which are then read by a Raspberry Pi Pico. The sound is generated by a TNC4, and there's a serial connection between them. True to the spirit of just grabbing whatever I had to hand, the LEDs are all handled by an Atmega chip down here, and that just listens in on the serial data. I'd never used a TNC before, but I like it. It's got a lot of grunt, and it's a very well designed system. The worst bit about it is that you have to use the Arduino IDE to program it, which I'm not a fan of. All of the knobs are digitized, apart from output gain. The problem is, if you have power supply noise and one of those knobs is coarse pitch, then it's a disaster. And you can tackle this by increasing the hysteresis on the knobs. That's what I did, but the proper way to do it would be to use op-amps to sum the three pitch sources in analog before they get to the ADC. However, I saved at least half a day of soldering time by not doing that. Sound output was going to be stereo, didn't get around to it. I'm quite pleased that I'm now sufficiently familiar with DSP that I can throw something like this together incredibly quickly and still avoid it sounding overly digital. I know where the aliasing is going to appear, and I know how to work around it. Some of the sounds are harsh and crunchy, but if you want it to be soft and smooth, it can be. Video is not a good format for explaining this stuff, so if you're interested in the gory technical details, as always, take a look at my website where there's more information. The link's in the description. I've shown this to a few people who've said, yeah, that's great, you should totally make a Eurorack version of it. And yeah, let's be honest, I'm never going to get around to doing that. But if you really want one, and you've got loads of money, I do commissions.
Wow.